All right, guys, so we're going to be starting lesson 2 here for unit 1. We're going to be solving some linear equations. So we're going to talk about general equations solving vocabulary and strategies, along with a couple special types of equations called identities and inconsistent equations. So I'm going to go ahead and read this first section here and then kind of jump into these notes. We'll learn many new equation solving techniques in Algebra 2, but most of all equations, but the most basic of all equations are those where the variable, say x, is only raised to the first power. These are known as linear equations. You need to have good fluency with solving these equations to be successful in Algebra 2, so let's start with some practice. What can I do with a linear equation? Well, first thing you can do is sort of observe. There are many different types of linear equations. Some are very simple, one or two step equations. Some of them have variables on both sides. Some of them have some, higher level simplifying that needs to take place. So you want to take a moment to observe your equations and kind of notice what type you have, what type of linear equation. Right? So that's kind of the first thing that we're going to be doing. Second thing is to simplify. So what we mean by simplify is we want to treat each side of our equation, each side of the equal sign, as expressions and simplify those expressions as much as possible. So if there's any simplifying, combining like terms, distributing, anything like that, we want to do that. So simplify each side of the equation. Okay, that's going to be the second thing. And the last thing is solve. Obviously, that is a very complicated process depending on the equation that we're looking at. We're going to be using what are called inverse operations to cancel out terms on one side and the other. So inverse operations are like addition and subtraction. Those are opposites of each other. And if you want to cancel out addition, you use subtraction. Same thing with multiplication and division. In the future, we'll talk about some other types of inverse operations, but for these simple linear equations, that's really all we're going to need to know. All right, so let's go ahead and take a look at our equation. What makes it an equation, you might ask? Well, an equal sign, right? If it doesn't have an equal sign, then we can't treat it like an equation. Sometimes people just treat expressions like equations. They're not quite the same thing. You need to be careful. There's definitely got to be this equal sign. Earlier on, I said that we're going to be treating each side of our equation like its own expression. So here we have each side of our equation. These are their own expression. And sometimes we're going to need to simplify those expressions. Looking at this equation right here, well, these expressions can't be simplified, so we'll just go ahead and ignore that part. There's going to be no simplifying that's necessary. But there will be a lot of solving steps. I'm going to go ahead and walk through my process of going through the solving steps. So I'm going to draw a vertical line down through the equal sign. So that's why I separate the left-hand side of my equation from the right-hand side of my equation. One rule to keep in mind, anytime you change your equation by adding something, subtracting something, multiplying something, if you do it to one side, you have to do it to the other side to keep it equal, to keep it balanced. I like to start by getting my variables on one side and then working with the rest of it. So I'm going to try to cancel out one of these x terms on one side. These are both positive. We have 8x's over here and 4x's over here. I'm going to go ahead and take away the 4x's on this side. I have positive 4x, minus 4x. In total, those are going to become 0. In Algebra 1, we call this a zero pair. They're going to cancel out. But I can't just do this to one side. I have to do it to both sides to maintain the equality of this equation. All right, so I'm going to subtract that from both sides, and then I'm going to reduce my equation down a little bit. 8x minus 4x is 4x. And then I have minus 5, right? I'm subtracting 5, so I need to treat this 5 as a negative value. So now I have my x's all on the left side. I don't have any x's on the right side of my equation anymore. I need to now get all of the numbers onto the right side. So I'm going to be canceling out this -7. I'm subtracting 7, or I could think about there being a -7 on this side. I'm going to make a 0 pair here using the inverse operation of addition. -7 plus 7 is 0. That's going to go away. But I have to do the same thing on the other side. Again, to keep it balanced, to maintain equality. Okay. 4x, bring that down. And then I have -5 plus 7. That's going to total a 2. It's going to be 2. And now, pretty close. Again, the goal of solving this equation is to get x all by itself. I want x equals a number. And in this case, what I have here is 4 times x, or 4 x's are equal to 2. To get rid of this multiplication here, I'm going to be dividing. Multiplication and division are inverses, so dividing by 4 is going to really turn this into 1, or 1x, which we can also just write as x. And that is going to be equal to 2 divided by 4. We have to divide both sides, again, to maintain equality here. And this doesn't divide evenly. I could either write this as a decimal. So if you use your calculator or something, you may get a decimal of 0.5. Or I could reduce this fraction. 2 over 4 is the same thing as 1 over 2. Either one of these are fine. It doesn't really matter right now. If you get a decimal that's kind of non-terminating, either non-repeating or repeating, we may sometimes prefer the fraction answer because that's an exact answer, whereas you may have to round your decimal, but they're both fine. Anyway, so that's our solution. X is equal to 0.5, or x is equal to 1/2. Something that's often very useful when you're solving equations is to use your solution to check it. Make sure that you verify that this is the right answer. And you do that by substituting the number that you got for your solution back into the equation for the variable. So everywhere there was an x, I'm going to go ahead and put 0.5 or 1/2, whichever one I want to use. So I'm going to go ahead and check that really quickly. 8 times 1/2 minus 7 equals 4 times 1/2 minus 5. I'm going to simplify each side here and just make sure that I do indeed get a true equal equation. 8 times 1/2 is 4 minus 7. 4 minus 7 is -3. Okay, so that's what I got, -3 on the left-hand side here. And I have 4 times 1/2 is 2 minus 5. 2 minus 5 is also -3. So I got -3 is equal to -3. That verifies my equation. That was the proper solution. So my answer, x equals 1/2, is correct. Again, it doesn't really hurt you to check it. You might as well do it, especially on a quiz or a test or something. Why not? All right. We're going to go ahead and look at 4 examples here. We're going to go ahead and solve these. I'm going to go somewhat quicker through them after we've done a few of these, but all right. Sorry. So here's our first example. We have this, again, this is a linear equation. The way that we know it's a linear equation is you only ever have just x's in there. You don't have an x squared, for instance, or maybe even something like a square root, or even possibly something like, what else could we have? Like, we could even have something exponential, but that would be kind of weird, an x in an exponent place. A lot of different things. We have x with no exponent written. Now, technically, that means that there's a 1 there to the first power. That's what makes it linear. Anyway, these are all linear equations. We'll talk about why the last one is as well. You do want to be careful. There are some times where equations may be something like this. They may have something like this involved in them. And this looks linear. It looks linear because, well, these are both just x's, but when you distribute, When you multiply, especially right here that I've drawn this arrow for, you're going to end up with x squared, and it's no longer linear. So you do need to be careful with that. But these are all linear, even this one, but we'll talk about why when we get there. This is a relatively simple equation. This is what we would refer to as a two-step equation. It's going to take 2 steps to solve it. That's why all of our x's are already collected on the left side of the equation. So we're going to go ahead and get rid of everything that's not the x over here and move it over to the other side. So in this case, I need to get rid of this plus 5 first. I'm going to use minus as the inverse operation. Positive 5, negative 5, that makes a 0 pair, and that cancels out. And do the same thing on the other side of our equation to maintain equality. 26 minus 5 is 21. And then here we have 3 times x, so to cancel out that multiplication, we divide. We get 1x, or just x, is equal to 21 divided by 3, which is 7. There you go. And we should check this. I'm not going to do it right now, but you could go ahead and substitute that back in and make sure that works as a solution. It does. 3 times 7 is 21, plus 5 is indeed 26. It works out. All right, next equation. Again, I'm going to go ahead and draw that vertical line. This one's, is this the same one as the example up there? I think it might be. Actually, yes, this is the exact same one, but this is an example of variables on both sides. So it's a little different than the first one here. When you see something like this, you want to make sure to get all of your variables on the same side of the equation. In this case, I got the x's on the left side, but you could get them on the right side just as easily. It just is a matter of how you see it, or how you want to work with it. I'm going to go and solve this one quickly. So subtracting 4x, that gives us a 0 pair here. And do the same thing on this side. 4x minus 7 equals negative 5. Forgetting to do the same thing on both sides is a really common mistake, especially when you're kind of trying to hurry through these problems. So, that's another reason to check them at the end, but also just to sort of take your time and get into that habit. Then I'm going to get all the numbers on the other side. I'm going to get rid of this. I'm going to add 7. Again, that makes a 0 pair. And we end up with 4x equals 2. Divide both sides by 4. And again, that's where we got the solution of a half, or 0.5. That was the same one as we looked at up above. And here's the next one. This one is a little bit different, a little bit special here. We have this bar here, which creates a fraction, but also represents division. So this whole thing right here is being divided by 2. So that's the way that I'm going to think about it. We have a couple different options when we're dealing with something like this. We have the option of distributing the division, dividing both terms by 2. And if that works out for you, that's great. That's certainly an option, and we'll probably see equations like that. But in this case, what I'm going to actually do is cancel it out. So the inverse of division is multiplication. So I can simply multiply both sides by 2, and that cancels out the division. There's a common mistake that people make. They multiply and they cancel it out, but they actually do the multiplication. You don't want to multiply those things out. You're multiplying in order to cancel that division out. It's going to leave us just with x plus 8. I have to make sure that I do the same thing on both sides. So if I multiply one side by 2, I have to multiply the other side by 2. And so here's what we get. I forgot to draw my vertical line, but I do really recommend that. Okay. And we're pretty close here. We have x plus 8 is equal to negative 12. So I have to get rid of this plus 8 by subtracting 8. Make our nice 0 pair here. And I have negative 12 minus 8. That's negative 20. So there we go. Again, you can substitute that answer back in there, make sure it works out for you. And yeah, there we go. All right, last one here asks this little observe question. It says, is this a linear equation? So is this an equation where we only have x to the first power? At first glance, yes, all of our x's are only to the first power. There's no x squareds, there's no square roots or anything like that that are messing things up. You got to be careful though. There can be times, like I showed before, where x squared or some higher power is actually hidden in the problem. That's not the case here, because when we do this distribution, nowhere will it force us to do something like this, where we have an x that gets multiplied in, creating the x squared, right? That's what would make it not linear. In this case, that doesn't happen. So yes, this is a linear equation. And we can verify that by just going ahead and kind of doing a little bit to this problem. So this is the first problem that we've looked at thus far in solving, where we need to look at each side of our equation independently and do some simplification. The left side of this equation is fairly complex, and we need to do some distributing, some combining like terms. We need to simplify this down a lot before we actually get into solving. So I'm going to go ahead and do this. I'm going to solve this one, but this is a linear equation. So let's distribute. 6 times x is 6x. 6 times 4 is 24. And then over here, we have a minus 2. So we're actually distributing a negative number. We need to be careful about that. Negative 2 times x is negative 2x. This is something that people will make mistakes on. We are treating this 2 as a negative. And now we have negative 2 times negative 1, which actually gives us positive 2. Because a negative times a negative is positive. I'll go ahead and rewrite this side. I'm not quite done simplifying the left-hand side though yet, because there are some like terms here that we can put together. So we have 6x and a negative 2x. Those can go together to be 4x. Positive 6 and negative 2 will go together to be 4. And then we have 24 and 2. Those will go together to be 26, adding those positive numbers together. And now we've reached a point where this problem resembles the problem B quite a bit. Each side has 2 terms and we have variables on both sides, but it's not too complicated anymore. We were able to simplify the left-hand side quite a bit. Now we want to get our x's on the same side. I'll do that by subtracting this 2x. In general, my strategy is to find the smaller x value and get rid of that one, or a negative one if we have that. But you can go either way here. This makes a 0 pair. That is going to leave us with 2x plus 26 is equal to 20. And we need to get the numbers on the other side, everything that's not the x itself on the other side. So we have this plus 26 that we need to get rid of. And I'm going to do that by subtracting 26, again, to make a 0 pair here. I'm going to go ahead and write some things in a different spot because I'm running out of space. We should end up with this equation. 2x is equal to 20 minus 26, so that's negative 6. And then we divide by 2, and we get x is equal to minus 3, or negative 3. Now again, we can check this solution. We can substitute this in. This would take a little bit longer to do this one, but we should end up with the same. This should check out to be just fine. Anyway, that was our solution. X equals negative 3. All right, let's go ahead and move forward. All right, now, similar to what we were doing when we were simplifying expressions, we have some rules that allow us to perform the operations that we're doing. These rules are called the properties of equality, which basically means that if you have a true equation, A is equal to B, so something is equal to something else, a true equation, you are allowed to add the same thing to both sides, subtract the same thing from both sides, multiply the same thing to both sides, divide the same thing, divide both sides by the same thing, and that equation is still true. Those allow us to solve these equations in the manner that we're doing. So we call these the properties of equality. We have the addition property of equality, the subtraction property of equality, the multiplication property of equality, and the division property of equality. Properties of equality. Again, basically what it says is we can add the same thing to both sides, subtract the same thing from both sides, multiply both sides by the same thing, divide both sides by the same thing. Division is the only one that's a little bit tricky. You're not allowed to divide by 0. That's just not something you're allowed to do mathematically. And multiplication, also you're not allowed to multiply by 0, because when you multiply by 0, well, you know, you turn everything into 0. So if your equation was not true before, you would make it true. It just gets a little complicated. 0 is a special thing. You're not allowed to do that with the multiplication and division properties. Anyway, all right, so we are going to explain each step that happens when we're solving this. We also have the 3 properties we talked about in lesson 1, the commutative property, the associative property, and the distributive property. We also may make use of those. Okay, so how did we get from here to here? What did we do? We distribute. That's what happened, right? So this is the distributive property. I'm going to abbreviate this dist-prop, distributive property of multiplication is what's happening here. Now what did we do? Well, how did we get from here to here? It looks like we combined like terms. That's what I'm going to say. Combine like terms. Okay, how did we get from here to here? What are we doing? Well, we are subtracting 14 on both sides, right? That's what we're doing. That's so that we get a 0 pair right here. To cancel out, we're subtracting it on both sides. So this is called the subtraction property. Subtraction property. What did we do? Well, we performed the subtraction, right? We just simplified. We actually performed the calculations. We did 44 minus 14. We did 14 minus 14 is 0. What are we doing here? How did we get to this step? We're dividing both sides by 6, which is the division property of equality. Division property. This is how you would sort of formally write this stuff down, making sure that you're citing the properties of equality and sort of the reasoning behind all the steps. It's not strictly necessary, obviously, when you're solving an equation, but we do need to make sure we understand there are reasons we're allowed to do what we're allowed to do, and reasons that we're not allowed to do some things. All right, let's go ahead and move down. We are going to talk about 2 special types of equations. Sometimes when you're solving equations, really of all types, but our focus is linear equations, where we get no solutions. We'll see what that looks like. That's called an inconsistent equation. And there are other times when we run into a situation where there are actually an infinite number of solutions. Any number will work for x. We call that an identity. So we have these 2 things, inconsistent, identity. And we have an example of each below here. So this equation right here is considered inconsistent. And let's kind of take a look at what's happening when we solve it. We end up subtracting, the first step is to subtract 4x from both sides. So that makes a 0 pair here, goes away. But it also makes a 0 pair over here, which actually just gets rid of all the x terms altogether. And that leaves us with this statement, negative 8 is equal to positive 1. But what we're left with is not a true statement. Negative 8 is not equal to 1. And therefore, since this is not a true statement, that means that this equation had no solutions. So we call it inconsistent. When an equation has no solutions, we call it inconsistent. Again, notice how basically In this equation, the x's all canceled out, and what we were left with was not a true statement, meaning no solutions, inconsistent. Here, we have an equation. It looks a little suspicious right off the bat. Both sides are exactly the same. But anyway, let's go ahead and take a look at what's happening. We subtract 3x from both sides. We get these 0 terms, cancels out all of our x's, and we're left with this statement, which is true, right? -7 is equal to -7. When we end up with something like this at the very end with a true mathematical statement, what that means is that all real numbers are solutions, which makes this an identity, which means no matter what number we substitute in place of x, this equation will be true. So these are kind of special types. We have the inconsistent equation, we have the identity. Let's go ahead and take a look at the one below here and see what type it is. Okay, we have a fairly complicated equation. We have variables on both sides. We have a lot of simplifying that's going to need to be done. And let's just see what happens. So I'm going to start on the left side. We have this -2 that needs to be distributed. Okay, so we'll go ahead and do that. So we have -2, I'm going to write it again, 6x. And then we have -2 times x, it's -2x. And then -2 times 4 is -8. Okay, a little bit complicated. Over here, we have this 3 that needs to get distributed. So we have 3 times x and 3 times 2 plus x. Whenever you have just an x, remember that there really is an invisible 1 in front of there. There is 1x with that, and then -5. You don't have to write it. I went ahead and wrote it just to remember that. We're still simplifying each side. There's some more that can be done. We have some like terms over here that can go together. So 6x minus 2x comes together to be 4x. 6 minus 2 is 4. And now this left-hand side is pretty much finished. There's nothing else here. These are not like terms. We're good with the simplifying on the left side. And then we have this side. We have some like terms over here as well. 3x and 1x is 4x, and 6 minus 5 is actually 1 plus 1. Okay. Right-hand side is simplified as well. Now we can start solving. So all of this was the simplifying part, right? We distributed, we combined like terms, and we simplified our equation. Now we need to start solving it. Again, my recommendation is to start with your variable, try to get that on one side. So I want to cancel one of these out. Let's go ahead and get rid of this one. So I'm going to subtract 4x to make that a 0 pair. I'm going to subtract 4x here, but that's going to make another 0 pair, right? I'm going to get rid of all of my x's. I'm going to be left with -8 equals 1. This statement right here is, it's not true, right? -8 is not equal to 1. That means that this is an inconsistent equation. There are no solutions. Again, the reason being is because we ended up with an equation that was not, we ended up with a mathematical statement that was not true. That means the original equation had no solutions to it. So again, no solutions, inconsistent equation. Kind of a couple different ways that we can sort of say the same thing. All right. Now, if this had been worked out just a little bit differently and we ended up with a true statement at the end, right? If we ended up with something like we had over here with a true statement, -7 equals -7, it's not an inconsistent equation. It's something that's called an identity. And instead of having no solutions, it would actually have an infinite number of solutions. Every number is a solution. Anyway, small difference, but actually quite a big difference in terms of what it means. All right. We're going to go ahead and stop part one right there, and I'll do these in part two.